Okay, so welcome to Advanced Programming course. My name is Mariusz. I'm Polish, but I spent some of my time living in New Zealand and now in Norway. So I sort of a little bit multinational. My Norwegian is not up to the level to teach programming. So this course language of instruction will be English, and language of communication in Discord and in issue tracker will be English. Um, if you have to communicate in Norwegian, I will try to follow. I'm trying to learn Norwegian, so teach me, test me. But for your own sake, I think improving the language skills in English are sort of good idea. So as I said, most of the stuff that we will do and the code that we will produce will have English comments, and we will sort of spend the semester sort of learning English and making it smoother for ourselves. Um, the course has two components. It has an exam at the end, and which is worth 40%, and it has portfolio, which is worth 60%. The portfolio is a collection of the things that you will do, and the things that you will do will be kept in your personal workspace. And to get the personal workspace, we have to use GitLab. So I talked about it at the beginning already. Those of you who have not asked access to GitLab, please do that today. And then request access to the course project. And then I will create, or the script will create the personal workspaces for the course. We will use course materials on the wiki. We will use the issue tracker for communicating concerns and issues. And we will use Git for collecting the portfolio. And a lot of work will be done through your personal workspaces, which you will have to have by next week, because next week we're starting the labs. There is one more thing, which is peer review and participation. So some of the labs you will have to physically be in the room to do the work. And you will also be required to peer review each other work through a certain system that we have for peer review. I will explain all those details next week when we actually start the labs. So if you have any questions, yeah, please post. Otherwise, we will use this Mentimeter to learn a little bit about what this course is about. So I will try to explain what we do in this course and what we will learn in this course. I expect you finished at least two programming languages already, like C and C++. Maybe B data students have finished Python and Java, but you have some fundamentals of using programming languages and some of the standard features such as for loops, while loops, looping in general, variables, literals, inheritance, structs, if statements, control flow. What else I expect you to already know? A little bit about memory management, pointers, and references. So all those you have already covered. And that's great. We will do a bit of a refresher. Next lab will be a little bit about object orientation and how we model problems and how we use them. And then we will move on to some additional constructs. How many mandatory assignments, and is it individual or group, and what group size? So good question. The course is individual. So you are individually graded and there is no group projects. However, as we move on with the labs and some of the group work in the class, there will be some some obligatory work that is done in teams, in groups during the class time. And then we will have groups up to 5 people. So we will have some ad hoc groups and up to 5 people grouping. And then you will complete some of the task as a group, and then you will have it ticked off. You will not be graded for obligatory work or for group work, you will be only graded for individual work, but you will have to complete some of the work in groups as an obligatory work without being graded just for ticking. So the course is yeah, individual, but we will do some group-based learning in the class through the labs and through some obligatory work in the class. All right, so any other questions? What does it take to get an A? I will post sort of like a table with all the constructs that I expect students to master for different grades. And then we can discuss it once that list is present. So it will be a little bit easier. So in general, we will cover quite a lot of conceptual work, and mastering all the conceptual work kind of will lead you to the better grade. We will come back to that once that list is posted on the wiki, such that we have something to concrete to base on. Okay. Great. Any other questions? If not, let's move on. So, first questions to you. List what programming languages you know. Can you answer? Yeah, great. System is working. So when there is a question about what programming languages do you know, it has two aspects to itself. One aspect is, do you know the syntax of that language? So can you express yourself in that language? So how do you write a function in Java? Or how do you write a function in Bash or C++? Right? So it's about syntax. The second one is about semantics and about constructs the language has. So for example, you might say, I know JavaScript, and you might say, yep, I know JavaScript. I can write code in JavaScript and I can read it. But you might have never used, for example, reactive RX frameworks in JavaScript. And you might not be familiar with reactive programming paradigm. And then you will not be able to kind of use it, right? And you sort of know the syntax, but you cannot know everything that the language has unless you learned all the semantics as well. And then you might come from Haskell and you have used functional reactive programming, but you never use JavaScript, but you know the concepts. So you know the semantics, you just don't know how to write it. So you may know syntax, you may know semantics, but you don't know the syntax, right? So this programming languages I know question has a little bit of it's kind of a little bit difficult to answer, because you have to think, how do you answer it? Do you answer it from the semantics of what you know about programming, or do you answer it from the syntax of which language's syntax do you know, right? And typically people think about syntax. And typically people say, yeah, I know JavaScript, but they don't fully know all the semantics that you can express in JavaScript, right? Great. So this is quite good. CSS typically is not considered a programming language, although it has a certain power to express itself. Same with Terraform. Yeah, it's like we're not gonna start like discussing what is and what is not a programming language. ChatGPT, not a programming language neither. But again, it's how we define the terms. Right, so print hello world. What language is this? Anyone? Right, so there are two great questions. All right, so first, what language is this? Yeah, it's Python. Great, Christian. some kudos. There is a question of should you have Linux installed? That's a very good question. I strongly, strongly, strongly encourage you to use Linux for this course, particularly because it's very, very, very useful to use Linux for the cloud computing course also. So you already have, killing two birds with one stone by using Linux. I know people did use Windows for this course, and I don't personally support that. Like, it is possible, but it's such a pain, even with Windows Linux subsystem, that I kind of don't. Yes, you can, but I don't support it, and I will not answer your questions. Like, you will ask me why it's not working on Windows, and I say, yeah, because you're using Windows. So use Linux and it will work fine. So just to like, we only have one semester, and there is no point solving Windows related issues because we have so little time that you will learn skills that are kind of irrelevant. Like, the relevant skills are about the languages and the programming, not about solving technical issues of Windows. Um, I personally, that's my personal opinion. I feel programmers are more productive outside of Windows platforms. And I encourage you to either use Linux if you have a normal PC, or use Mac if you are kind of a Mac user, and Bash. And then things will be much easier. If you're stubborn and you do want to use Windows, you can, but you're kind of on your own, and I don't, encourage that. Do I recommend full OS or dual boot or VM? It doesn't matter. Again, as my personal opinion, I do recommend just full OS and kind of move out some of your life online, like and programming life into Linux, because it will be safer and it will be easier in most cases. If if you're fully committed to only supporting Windows platform, and you kind of see yourself, let's say, as a game developer who primarily targets Windows, then maybe you have to do both. You have to live partially in Windows and partially in Linux. But for majority of people, that is not the case, and you will have to support multiple platforms, and then it's easier to support multiple platforms if your primary platform is Linux. Um, so I do recommend full OS, but yeah, it's fine if you just want to spin off a VM and kind of do all the Linux related work for the courses in a VM. It's okay. Dual boot is the worst case scenario. Like, rebooting a machine, it's like just a wasted time. So either get yourself two machines or use VMs if you have to have both. Um, I I didn't have really good experiences with dual boot. It's sort of a pain. Um, it's easier just to have a dedicated machine for one OS and just have a full OS on that machine. Yeah. So if you're playing games and you want to have, Windows game box, game machine, just keep Windows there, but make your laptop or make your like mm, secondary device Linux only. I don't know. Like it's up to your kind of situation. Um, Right, so that was one question. The other question was, is Bash a programming language? No, according to my definitions, Bash is scripting language, but those are sort of nuances of what constitutes a programming language. We will dive a little bit into this, and we will sort of think what makes a programming language a programming language. So hopefully by the end of this course, by the end of semester, you will have your own intuition of what makes a programming language, and what makes a scripting language a scripting language, and what are kind of the categories of languages that we use for different tasks. All right, so print hello world. So in which languages can you do this? Can you write a hello world program? So hopefully this is much bigger spectrum of languages, right? So as I said before, knowing a programming language has two components, has the syntax and semantics, and then Hello World is really low, both on the syntax and on the semantics. You don't need to know a lot about the language semantics to be able to write, Hello World. Um, so we should be able to see more languages now than we seen on the previous slide when I ask which programming language do you know. Um, great. Six more people. Question. If the most used OS is not supported in this class, this should be communicated well before the semester starts. What would that change? What if Microsoft decides to go bankrupt next year and there is no Windows next year at all? And we live in the world with no Windows. Yeah, we have to be a bit agile. Um, so as I said, I personally don't use Windows and I cannot support it because I am not skilled enough to solve the technical problems that people might have using Windows. But some of other students in the course will use Windows, and some of the TAs might be able to help you. And you can solve your problems using online resources. So I don't really see a problem. As I said, many people used Windows for this course in the past, and they passed the course, and it's okay. But I am honest with you, and I don't use Windows. I hate Windows, and I don't know much about Windows. And if you ask me questions about Windows, I will just don't know the answer. So that's how it is. Yep. All right. So we see a little bit more spread here, and we get an intuition that knowing a programming language has sort of a degree, right? So those of you who did the operating systems course, you know the dining philosopher's problem. So for those of you who don't know it, it's sort of a problem for concurrency and resource usage where you have multiple philosophers sitting around the table and there are forks and knives kind of between them. And to eat, the philosopher has to grab the fork and the knife, which means the philosopher to the left is missing a fork, or yeah, the one to the left is missing a fork, and the one to the right is missing the knife, or some form of that. And then they eat, so they consume resource, but the other two philosophers have to wait for the kind of coordination for the fork and knife being available. So then to kind of like if the particular philosopher is never getting two resources like the fork and the knife, then they cannot eat and they starve to death. And then some of the bad behaviors in concurrent programming can happen. So this is a kind of a very hello world problem for concurrency programming. And the next question is, can you do this problem in one of those languages again? So it's different than writing hello world. It's kind of a much more semantically rich and kind of complicated problem to express. And which programming language would you be able to do it in? Yeah, I hope some of you might have been doing it in the operating systems course. Um, so I haven't talked with Eric recently, but I know he was using it at some point. Um, It's about concurrency. It's about using locks and semaphores or some other mechanisms for coordination, using threads or green threads. In general, about using concurrency. All right. So as we can see, now the picture is a little bit different because this time it's much more kind of a more in-depth understanding of the semantics of the languages, right? Um, question. Yeah, I'm asking if you can do it without online resources or if you know how to do it yourself without, asking ChatGPT to do it for you. Um, so if you write a code which does not compile and has some quirks that needs to be fixed, that's okay as well. So you don't have to write the fully kind of a correct code, but you can write code which has all the constructs that you need to use, but you might have missed some, yeah, there might be some typos or you've used like something quite, not quite correctly, and then you need to just fix it. That's okay as well. And for that, you can use online resources. All right. Yes, that's right. Not perfect syntax, but logically correct. That's right. That's what we're after. All right. So I can see if we go back to this picture, we can see it's a little bit different this time, right? Um, so some people were saying, yeah, we can do C# and Golang, Hello World type of things, even in Haskell. 9 people were quite good in, like confident in Java, and then this sort of weed out some of the votes and also drop down kind of a Java concurrency. So you like if someone says, I know Java, what does that mean? Do you know Java on a Hello World type of problems, or do you know Java like with concurrency or some, more complex semantics? So what this course is about leveling up your semantics. It's not, as I said, actually focus on syntax. It's more focused on semantics, that we know the constructs and we know the things that are needed to do something in a particular paradigm or particular programming language. So, for example, those people who kind of can do it in C or C++, they know certain constructs like threads, locks, semaphores that can be reused in Golang, for example. So doing this similar pattern here and in Golang or Java is just a matter of syntax because you already have all the necessary constructs. But some constructs in JavaScript or in Haskell are different to do concurrency. And then the low level features or low level constructs that we use here are sort of not useful for some languages, and not knowing the semantics will kind of prohibit you to do it in other languages. Um, so again, this course is about constructs and semantics, which may not necessarily exist in all programming languages. So we will learn certain things that are either really, really hard in certain syntaxes or certain languages, or impossible because they don't exist there. So this is sort of the spectrum. What is the best language to do dining philosophers problem in? So if we were to solve the dining philosophers problem in the most perfect language for that problem, what that language would be? And then the question is, okay, what does it mean perfect? Well, it's a multi-criteria kind of a goal. So the first one is how easy that would be to do it, how easy that would be to solve it. Like in terms of lines of code or complexity of the code. The second one, kind of a maintenance, how easy is to find bugs and maintain or add features to it. And then the third one is like how performant the solution is. So we kind of can say, okay, performance is the key, like everything else is secondary, and then we probably should do it in assembly. Or we can say, yeah, we have to balance the different criteria, right? So if we sort of imagine this very abstract way of balancing everything, where everything is kind of important, what would be the best language for dining philosophers? So I can see that some people kind of really highlight C, C++, and that's not surprising because of this. Most people are familiar with this constructs and those languages. So they probably say, yeah, I see nothing wrong with doing it in those languages. But again, this course is about you expanding your understanding of programming languages and understanding a little bit more on what makes a tool suitable for the job. Um, so we will discuss it a little bit in a bit. So this course is transitioning course. So it transitions us from a certain level of understanding programming into sort of leveling up to the next level and broadening our perspective. So we have certain biases uh, based on the history of what we were learning and how we were learning it. And then we're gonna expand a little bit our horizon and a little bit our perspectives into things that we don't know about, right? So the whole thing is to learn about things that we don't know about yet. Um, to tell you kind of a story, I learned programming actually from assembly. So the first programming language that I learned was a Sinclair Z80 microprocessor, and I learned how to program it in assembly. And it was fun. I loved assembly, and I thought, yeah, that's the best, language for the job, for any job. And then I learned BASIC. And I was like, whoa, shit, man, Basic is like such a good language. Like it's such easy, so much easier to make more complex programs in Basic than in assembly. So making like small games was trivial in Basic, and it was like months and months of work in assembly. Okay, so I love Basic. So my first love was assembly, then I love Basic. And then I was learning Pascal. And Pascal is sort of very similar to your current modern languages, like maybe C++, or Java. And I was sort of learning Pascal, and they had this kind of a construct, like you have the functions. So in Basic, I was sort of using a go-to statements for loops. So you write your statements, and then when you need to jump, you have if statement or you have go-to statement, and you go to a line number, and then you kind of loop. And in Pascal, I was learning about for loops. I was like, what the hell? It's like such a complicated thing, like this counter thing and all this. It was like serious kind of mental challenge for me. So I spent maybe like 3 or 4 days kind of learning for loops, and I just couldn't get it. Like I had to ask my friends, like, how does that work? But once I got it, it was kind of fun. Like I learned that you can express different things in different way. Um, and the journey sort of started. So you are biased by the first things that you learn because they are familiar to you and you understand them, and you have aversion to the things that you don't know yet because they are hard and you don't quite understand it. And as I'm telling you this story, I'm like puzzled, like how easy construct like a for loop can be hard for someone who was not experienced with who was experienced with jumps and goto. Because I was really biased from assembly and basic just to do jumps. And then the for loop internally, of course, it unrolls into jumps, but um, conceptually, it does not work on the jump level. It sort of is this looping concept, and it's really different to jumps. So I had to learn it, and you will notice that throughout your career and throughout the new things that you learn, that you have those mental blocks that limit your ability to comprehend, to understand something because you have bias coming from your previous experiences. And this course is to sort of break some of that. And some students really enjoy it, and some students really hate it. Again, it's a little bit about your personality, like how easy it is for you to dive into unknown, to something that you kind of don't understand. Um, so it's a little bit difficult to explain the very nature of this course, but let's say you're learning how to build bridges, okay? And that's your bridge, like that you typically build for your villagers, and you know it does the job. You can cross the river, right? But there are some limitations to how the skills can take you if your skills are limited to making bridges like this, okay? And then there is a whole world of different bridges. Like there are wooden bridges, there are, you know, suspension bridges and concrete and metal bridges that have to carry, you know, heavy trucks, and so on and so forth. So depending on the nature of the problem, you have to use appropriate tools. You know, you cannot build bridge like this for multi-lane highway using the skills that are, you know, able for you to do this type of bridge, right? The skills, like the physics is the same, the material science is the same, but the skills of using the physics and the skills of using the materials is different. It's not only about the scale, it's also about the way you think about the problem and how you approach it. And obviously, if your goal is to solve this problem, which is crossing a river in the middle of the forest for, you know, 100 people a year crossing it, using the skills and technology needed for this type of bridge would be an overkill. So we don't do that. We kind of try to find the tool for the job and be skilled in using the tool for the job. Can you master all of this? I don't think so. So you will have to specialize because the programming as a domain is so vast and so big that you will not be able to be a master of everything. You can only kind of master a certain type of domains or problems and be really, really skilled for that. We will come back to that in a moment. Question. How often do we take breaks? Yeah, I think the time is come. Let me see. Um, so let me quickly check. Ooh, I cannot quickly check it without. Yeah, I have to make a break now. So just to close this one, the best language for solving the dining philosophers is Erlang. Is the language developed by our neighbors in Sweden for telecommunication systems, which have to run forever without reboots, without crashes, and without maintenance, and which have to be extremely performant because there are millions of concurrent calls happening all the time in the telecommunication lines, and it has to work. So Erlang was designed specifically to solve dining philosophers problem, and it's the best language for the job. It uses an actor model, which is a kind of a programming paradigm that is not mainstream, and we typically don't do actor model, although it is becoming more popular these days because of AIs and kind of AIs talking to one another, and it may have sort of a renaissance coming along. And we will learn a little bit about actor model in this course as well. So let's have a break. I will start a timer perhaps. So how about 10 minutes? Okay, 10 minutes break. Let's see. Yeah. All right. So Erlang. So you've learned now a new programming language name, Erlang, which is really cool. Unfortunately, we don't have enough space in the degree to teach you about Erlang. But we will do a little bit about actor model. And then once you know the actor model, then migrating to Erlang, it's not automatic. It's not easy, but it's easier. And also, Erlang has quite nice features. One of the nicest features of Erlang, I've been quite fascinated with Erlang when I was a student. And I actually did a small Java-based Erlang-like system, which allowed me to, on the runtime, to replace some of the code which I have. So let's say you create a class and then you have a running system and then you say, okay, I would like to introduce a new class member or new function into my class, but not as an inherited one, as added library, but actually change the behavior of the stuff that is already running. And in Erlang, you can do that. You can sort of isolate a module and say, okay, we're gonna replace it with a bug fixed version without rebooting the system or restarting the system. We just migrate dynamically what's currently working with this new thing on the fly. In Java, you can do that a little bit, but not quite. Why not quite? Because the class loader, which loads all the classes, it kind of keeps the copy of the old stuff. And then every time you say new, let's say you've modified a person, the class person, and in your code, in some places you say new person, blah, 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 right? So then you can substitute the definition of the person with your new one, but all the objects which have been created with the old one will continue to be the old one until they are garbage collected or kind of disposed. But every time your code calls new person, the new person will be kind of created, not the old one. So you can kind of see that over time you can migrate your system to the new one, to the new version one, but the old person class and the new person class are actually different classes. They have the same name. They kind of from the code perspective they are identical, but from the class loader perspective that they are not. So Erlang has this kind of a nice feature of on the fly reboot of what you already have in the code without like restarting, which is quite unique. Like not many programming languages, like in C++, definitely you cannot do that. Everything is compile time, not runtime. With some languages like Java, you can do a little bit, but not as fully as in Erlang. So there are some features that make Erlang quite unique. But as I said, Erlang is not a mainstream language. It's only used in very specific niche areas, and we have limited amount of space in the degree. So it's not in the degree, but those of you who are interested, I recommend kind of reading and learning a little bit about Erlang. All right, let's move on. So what do we use most? Um, what programmers use in their work the most? Yes, we do use brain. That's the, ultimate answer. Um, what else do we use? We use many things. We use computers, we use keyboards, we use ChatGPT, we use AI, and we use AI more and more. Um, we use fingers, yes. But what we use the most? What is that programming cannot happen without? So I think. mm, So we have to answer this question by elimination, right? Um, can you do programming without IDE? Yes, you can. Can you do programming without AI? Yes, you can. Can you do programming without Git? Yes, you can. So like the most is changing. Um, but if we eliminate what we cannot do without, that means that one thing that we cannot do without is the most because it's always there, right? So which one is always there? And it's the brain. So we cannot do programming without the brain. And we're gonna do a lot of stuff in this course, but the course is ultimately about you changing your brains, and me changing my brain. Programming is quite cool because it is something that is not fixed. As I told you, the story of me kind of learning programming from assembly, um, it sort of never stops. So the programming languages we use today, or the operating systems we use today, might not be the programming languages or operating systems we're gonna use in 10 years. It's all changing. Some ideas remain, but like the field is kind of in the flux, and you can have an impact. You can kind of do things that are new and they are popular and they become the mainstream, or they solve some niche problem that like in a new unique way. So the first of all, the field is really big, and second of all, it's sort of in a flux. Um, there is no single correct answer. So as I told you, like in assembly, I use jumps a lot. And then in basic programming and basic, I use jumps a lot. And then I learned that using goto statement is a bad idea. So how come? Like how come we design languages with goto statements and then we learned that it's a bad idea? Well, things happen, right? We have certain ideas first, and then by millions of people using it and doing millions of problems, it turns out some of the ideas are not great. One of such ideas is object-oriented programming, actually, with inheritance. So using object-oriented programming with inheritance turned out to be, in most cases, a bad idea, and it's sort of frowned upon. So some of the modern programming languages, like Rust, for example, we don't have inheritance. In Golang, you also don't have inheritance. You have certain object-oriented patterns and features, but inheritance has been sort of dropped because it had more problems than benefits. So some ideas and some concepts change over time because we learn that those are bad, that they are kind of that they don't work as well as we thought they will. And the same, everything we learned in this course, it may turn out that like some of those things are not as good as we thought, and new things came along, and it's kind of exciting to be in the field and sort of follow up the different patterns. So programming versus coding, that's often confusing. It's a simple topic, but it's kind of confusing for non-programmers. Okay, question first. Um, Developer access, yes, that was the answer for the thing. And modern C++ also avoids inheritance. Yes, that's right. So that's the kind of things that change. Like the way I learned object-oriented programming, like many years ago, is different to how you should learn it because we know now more of what works and what doesn't. So programming versus coding, simple one. All right, we have quizzes and we have leaderboards. So some of you will like it. Join in. Only 7 questions, so you have to pay attention. All right, all right, all right. Can we have 30? Yes, we can. Great. So let's start. Is programming and coding synonymous? Lots of quick answers. Hopefully correct. Yes, they are not synonymous. Unfortunately, it is often used as synonyms in the popular magazines or popular media. And like if you try to explain to your parents who are not programmers, they may not understand and they may not see the difference. But programming and coding are not the same activity. They are different. So what is programming? It is great. While you're doing this, let me just go back to here and go to wiki. We have this very academic or very maybe abstract definition what programming is. So programming is a process. Okay, so we have a keyword, it's a process of creating. Okay, so representations. So this is what programming is. It's a process of creating representations. Um, if you think about it, if you have a problem to solve, um, you usually changing one form of problem statement into another way of stating the problem in such a way that you can solve it. So problem solving in a way is translating what the problem is expressed in one way to what the problem is expressed in another way in such a way that it's actually solvable. So the original statement means we can understand what the problem is, but we don't see how it can be solved. And then we're translating it into a formulation which allows us to solve it. So capturing the definition as problem solving is probably the closest to a normal language that we can use. Um, and then the rest follows. It is kind of um, like we often like how do we solve problems with friends? We like so let's say your friend has a problem, she or he tells you that problem, and then what normally happens? Normally, you reframe it or you try to kind of say it in such a way that it can be solved. And it's not obvious sometimes. And sometimes it's a kind of invisible to the person having the problem, but it's visible to you. And then together, or you can sort of solve the problem. And it's this reformulation of how things happen. So if we kind of think about it, like what do you do with ChatGPT or with AI? You're formulating instructions, you're formulating certain task, and then the AI kind of translates it into a code or translates it into a specific way of addressing it. But the initial input happens in your head, and it's this sort of the change of the formulation into a new format that can actually lead to the solution. So I like the definition which sort of focuses on problem solving, because it is kind of the closest to this process of creating symbolic representations definition. Um, I kind of hope that you will sort of get a little bit more later as we progress with the course. But That's what programming is. So what is coding then? So if programming is problem solving, what is coding? Yeah, yeah, it's good thinking. Yeah, it's good thinking. It is a little bit philosophical and a little bit maybe mm, it's a little bit difficult to capture the actual like boundary between where one and the other kind of finishes and starts. But the idea is that programming happens in your head. It's the way you formulate kind of the representation. You formulate the problem into a different way of structuring it. We will spend the first lab a little bit on this to see how two different framings of the same problem can lead to different outcomes. So problem solving kind of happens in your head and it is yours. But then you have to communicate it. You have to either communicate it to the machine to understand it or interpret it, or communicate it to another human. And you have to convert what happens in your head to something that is expressed in a language. And this conversion from the idea to the language is what coding is. So coding is, yeah, writing code. It's basically writing instructions. It's kind of converting what happens in your head to something that can be communicated to another head. So how I solve a problem in my head um, needs to be expressed in a way that either computer or compiler or ChatGPT or another human can understand it. So coding is that process of converting an abstract representation into something that can be interpreted. And as you see in the definition, that are to be interpreted is part of the definition of programming. So, kind of programming without the coding cannot be interpreted because it is kind of like you are the only interpreter that can do that in your head. But if you are the only one, that's kind of not enough. You need to convert it into something that can be interpreted by somebody else or by the machine or by ChatGPT or by another human, right? So programming and coding are kind of intertwined because this conversion, this expression in the language is part of programming in a sense. But you're kind of doing programming in your head with all the constructs that you have in your head, and you are the first compiler and the first machine that interprets it. And that's the first step. And that's what the kind of happens in your head. Right. So so contemporary LLM-based AI systems can do what? What they can do. So you all experience ChatGPT and Copilot and other AI tools. What can they do? You can take multiple answers. So they can do multiple things. Right. So let's have one more question about this one. So let's say what can um, what can do the best. So out of the different activities, kind of say what they are really, really good at. So the LLM-based AI systems. Um, So order it in the way they are really good to really bad. Yes, I think we have a little bit of a pattern. And I agree with what you say. I think the pattern is sort of similar. Here and here. So we see that majority of people say, yeah, it can translate, and then they can code and write specs, and like the least people say it can program. It's sort of similar here, like the least people say it's program, and the kind of translate wins by big factor. And I think that kind of communicates really well what AIs are really good at, like especially the LLM based AI systems we have currently. They are really, really, really good in translating. Um, and the other activities, especially the problem solving, yes, I think AI systems can do problem solving, especially for trivial problems. For very complex problems, they are not that good. They are still much, much weaker than humans. But for simple problems and small problems, they are kind of decent. But in translation, they are superb. They also quite good in coding. So if you have solved the kind of the problem in your head and you express it in some form of spec, they are quite good in kind of converting the spec into the code if the spec is well written. How well AIs are in writing specs to humans, I feel they are not that great actually. So if I'm often a little bit frustrated with that feature of AI systems, especially for more complex things. I often see they miss the kind of key aspects of what is needs to be in the spec. Um, but translating and coding are quite good, especially for not very complicated things. Also quite good in scripting for like Python or some small scripts. They're quite good too. So maybe I would kind of order it a little bit differently, but definitely translate would be number one and programming would be number five for my field currently as well. But we will learn more. So in this course, we want to get more insights into that as well. We will use AI systems for all of these, and we will see where they are really good, can help us, and when they don't help us much, and we just have to do, task ourselves. Otherwise, we just wasting time. So it is not about not using AIs or delegating everything to AIs. It's sort of finding the point where we should use AIs and where we should not. And it's quite hard. So sometimes it's kind of hard to tell for a particular problem or particular situation what is the best course of action. Same as choosing a tool. Which programming language should be the best for the particular job and so on. So we kind of trying to learn in this course those kind of decision points. Um, Okay, what is the difference between script and code? Um, Good question. So let's leave that question open for now, and then we will come back to that one. All right, let's move on. Okay, how you judge your C11 skills? Okay, how skilled are you in C11? So you spend some time learning C, especially the BPROG people. If you are from B data, maybe you didn't spend much time learning C. But how would you judge your sort of C foo? Great. All right. That is really good. Let's see. Let's see how that pans out for the next question. And the next question is a quiz. So join in. If you were kicked out, can we have 30? Maybe not anymore. 29. Yeah, maybe we can have 30. Come on, come on, come on. 30. Perfect. Question. What is C11? C11 is a version of the C programming language, ANSI C, which has been developed around 2011, and it's sort of the I'm not sure if it is the latest one, but definitely one of the latest iteration of C language. Um, the typical C that I've used when I was a student was the old-fashioned C, and then we had a standard which was called 1999. It was called C99, and that was the standard which has for many years been the kind of de facto modern version of C. And then C11 is sort of the latest reincarnation. So let's start the quiz. So ANSI C in 2011 has introduced the following: atomics, multi-threading and atomics, collections, garbage collector, or generics. Which features have been introduced into the language? And it's both. So it's, I mean, those two answers are partially correct because it did introduce atomics and it did introduce multi-threading, but that is a better answer. Um, there are no collections and definitely not garbage collected. Garbage collected languages are different, and C++ are the sort of manual memory management languages. So the garbage collector has not and will not be introduced. You can use extensions. You can use extensions to C++ or to C with a particular implementation of garbage collector, and then if you use it, or you can write yourself a garbage collector, but the language itself will never have it because that's the design principle for those languages. All right, so we have some uh, good performing and better performing students. Perfect. Mina is the fastest so far. Okay, so what programming paradigms do you know or have you heard of? Functional programming. What else have you heard of? Multi-paradigm, yes, but that's kind of a, supermarket type of thing. Object-oriented, reactive, yeah. Declarative, yes, nice. Imperative, imperative versus declarative. Reactive is very interesting. We will spend some labs on the reactive programming this semester. We will spend a lot of time on functional. Next lab is about object-oriented, event-driven, yes. Vibe coding, that's not a paradigm. Okay. What else? So object-oriented and functional, those are sort of a mainstream. And when language combines both, we say it's a multi-paradigm language, okay? Event-driven and reactive are usually added to mainstream programming languages as extensions, and you can use it for particular types of problems. Um, Asynchronous programming, yes, that's part of the concurrency models of how different languages allow you to do asynchronous programming. We will spend some time diving into functional, and there are other paradigms. So I thought you will not mention reactive, but you did, which is great. I already mentioned a little bit about actor-based, and there is one more, which is constraints based. So compared to your list, the reactive is there, great. But the other two are missing, and the other two are still quite mainstream. Like they are quite important, such that you should know about them because, like, 99% chance is that you will be faced with problems that are really suitable for one of those three. So knowing only OO and FP is sort of, handicapping you, because if you know one of those three, you will almost always hit a problem which is better for those. But the picture is sort of nuanced. So you do have niche paradigms like constraint, probabilistic, reactive, actor-based, and so on, which are kind of niches which you may end up using, especially if you are kind of a good programmer. So for some applications, it is a little bit like a pyramid, right? So on the edge of the pyramid, there is a small number of highly skilled people who can solve the niche problems, and those kind of paradigms fit really well there. Is concurrency a niche? Not anymore. I mean, with multi-core machines, almost everything is about concurrency. So concurrency sort of shifted from being kind of a niche more towards mainstream, but it's not in the mainstream as such. Like, you will have to care about it if you're creating frameworks for other programmers and so on. But if you're sort of in a business logic, business sort of apps and long-lived systems, you usually are kind of in a mainstream. And in a mainstream, we have object-oriented, procedural, functional, but not functional like Haskell, but functional kind of in a small functional way, that you have some sort of like you're using a map or fold and that's it. So there are some sort of for CRUD. What is CRUD? What does CRUD mean? Um, Break. No, answer what is CRUD first. Break in few minutes. Perfect. Create, read, update, and delete. Fantastic. So this is your typical bachelor thesis applications. You typically do CRUD-based applications. Some of you may do something here on that side of the spectrum, but 80% of bachelor theses are kind of CRUD systems where you have a database, backend, front end, and you kind of creating, deleting, and updating stuff on the way. There is nothing really fancy happening. And for that, the mainstream approaches are perfect. But if you're creating frameworks, if you're creating domain-specific languages for other people, if you're creating some libraries, or if you're solving some kind of a niche problems, you usually on the blue. That's where those other paradigms kind of fit in. We will have a break in a moment. Let me continue. So we learn a lot about terminology and how to be precise in saying what needs to happen and what is happening and what do we really need and what do we really want to use. So in terms of languages and in terms of categorizing languages, we have sort of this terms coding versus scripting versus programming. We're not gonna dive today into this, but we will spend some time demystifying what those terms mean. And then statically typed versus dynamically typed languages, with or without type inference, declarative versus imperative, that has been mentioned already. You are familiar with the declarative and imperative terms. Compiled versus interpreted versus bytecode compiled, or just-in-time compiled. We will dive into that a little bit too. Rich versus limited standard libraries, lazy. So rich versus limited standard libraries. So for example, Golang is a very nice language with a very rich standard library. You can program most of the things without using external dependencies. And it has a lot of benefits. Like, one benefit is maintenance. You don't depend on another people libraries, so you're sort of easier to maintain your code base. Also, you are less susceptible to dependency attacks or to kind of supply chain attacks on your code bases or complex systems, because you're basically using the language standard libraries which are shipped with the language. And then limited standard libraries like Rust is an example of very limited standard library, and almost everything is done through crates and additional kind of libraries. So then the benefit is that people can do things in different ways and more efficiently, rather than the language designers doing it in a single way for everybody, right? So here you have more niche solutions for various kind of niche things. Here you have kind of one size fits all, but it is safer and easier to maintain. So there is no kind of silver bullet, never. There is always kind of benefits or drawbacks between different things. Lazy, we will talk about it a lot in Haskell, with or without memory safety. Like, C comes to mind. So that's a very typical language without memory safety, or C++ in the old way. The new ways of using C++ kind of added more and more memory safety into the language. And if you use it properly, you do end up with some guarantees and some memory safety, but the design of the language was like, we don't want to kind of do memory safety by design. Rust, again, is a language which is manual memory management, but with strict memory safety, right? And then with or without garbage collector, we talked a little bit about it already. So then we have a lot of terminology related to actual programming. So encapsulation, type, systems, objects versus instances, classes, pointers versus references. So for some people, like, they don't see a difference between what an object is and what an instance is, or what a pointer and reference are. We will dive into that a little bit more. About variable, immutable, and mutable versus constants, literals, polymorphic literals, functions versus methods, pure functions, side effects, and so on. We will learn more about those terms as we kind of use the code examples and languages that we are studying this semester. But all those terms are sort of, I'm putting them on the slides on the first lecture, because all of those are part of the exam. You will have to know and be kind of fluent and automatic about understanding and using all those terms. No sloppy usage. You have to use those terms and express yourself kind of properly. Classes versus traits versus meta classes. We will experience all three. You already know classes from Java or from C++. Maybe you know traits from C++. We will learn more about traits and meta classes, and how the complex type systems work. We talked already about inheritance a little bit. We will spend some time talking about generics, and hopefully in Christopher's course, you will also use generics in Golang. All right, and then kind of how the programming actually happens. What are the arithmetic operations, logic operations, control flow, expressions versus statements, especially important in Haskell and Rust to know the differences. And then we spent quite a lot of time talking about polymorphism, because it's a very, like, you know some things already from C++, but you don't know everything. Like, C++ is quite limited in terms of polymorphism. Right, so let me see. I have 3 more slides and then we will have a break. So as I said, this semester, if you in the BPROG, you're gonna learn 3 programming languages, or about 3 programming languages. And if you not taking Christopher course, you may not learn Golang, but Golang you will learn in a cloud technology course, and it's a contemporary C. It's a sort of following same principle and same target audience as C, but it has much more modern feel. It's very easy to learn. You can learn Golang in like 3 days. Seriously, there is nothing difficult and nothing surprising about Golang. Okay, there is one surprising thing about the references and passing by value or passing by reference, which is a little bit of a gotcha because Golang is a garbage collected language and it has a little bit unique way of deciding what is passed by reference and what is passed by value based on how the program actually is written, not by the syntax. So the syntax for passing by value and passing by reference is the same, but sometimes the value is passed by reference because it only makes sense to pass it by reference, and sometimes it passed by value. So there is this little gotcha, like it has this little quirk, but other than that, it's very easy. And it has a very nice concurrency features, which are, again, are very easy to learn, much easier than C++. And it plays great with Docker because you create very small runtime executables, and it's very great for building larger projects. That build times are kind of amazingly fast. You will see that compared to Rust or Haskell, how much pain it is with Rust and Haskell, especially with Haskell. But with Golang, it's kind of like no issue. It's also great for networking. So it's a kind of a system level programming language, which has great support for networking concurrency and being used with Docker, which makes it a perfect candidate for backend systems. So that's the language that you will learn in cloud course. Rust is an alternative or kind of evolution of C++. Some people say, yeah, it's like not needed because C++ goes the same way. But I disagree a little bit. So Rust has a very Haskell heritage. It has a much more functional programming feel, and it has kind of, it sort of feels like Haskell done for manual memory management. So they really try to reuse a lot of constructs and patterns which exist in Haskell into a language with manual memory management. And that's what the biggest difference is compared to C++. C++ will never have it. C++ has, lambda functions and some functional feel, but it is so difficult to use that it will never be usable that way. Anyway, it feels really modern. It's very good for embedded systems. It's very expressive, more expressive than C++, but not as expressive as Haskell. Like the expressiveness of Haskell is kind of unmatched by other programming languages. And it's kind of very used for mobile or cross-platform or embedded systems. It is also used for systems programming, and Linux kernel supports modules written in Rust now, as kind of modernizing the tool chain for complex systems such as kernel. Question. Why does Rust feels modern? Because it has all the supporting features such as the crate management, syntax checker, code tidiness checker, and everything built into the language. Same as Golang and same as Haskell. C++ does not have it, and C does not have it. So for example, if you're writing C, you have to use external tooling for doing checks about your syntax or about kind of linting of your problem of your programs and so on. Whereas like Golang, Rust, and Haskell, they all have it all built in. They have linters and syntax checkers and kind of bug detectors. And Golang even have this sort of a very primitive concurrency check, which checks if you have some race conditions or some hanging threads if your program finishes and so on. And C or C++ does not have it. So they are kind of, they have this old feel where everything needs to be handled somehow outside of the language, whereas the modern programming languages, they have it all built in. Documentation, management, and so on. Java also feels a little bit on the modern side, although it still lacks like default code, syntax checkers or linters. They tend to be external. Whereas Rust, Haskell, and Golang, they have it as part of the language, as part of the sort of a compiler toolchain that you're getting with the language to use with. All right, and then the final one is Haskell. It has the most focus on fundamentals of what programming is about. It is a precursor or grandfather of many programming languages. So if you know Haskell, you sort of know semantics of a lot of programming languages because they've been like taking it from Haskell. It will possibly change the way you think about programming. It will definitely make you a better programmer because you will understand more complex concepts and constructs in a very succinct and expressive way. It's ultimately expressive, and it's great for very large and complex systems where you cannot allow yourself to have bugs. So Haskell is used in production in industrial systems, especially in security and in finance, where you cannot allow yourself to have side effects or bugs or sort of side channel attacks. That's where Haskell kind of shines. But it is definitely not a mainstream language. Like it is rather on the niche side. So if we were kind of seeing that picture, um, it sits definitely here. It's kind of exploratory and kind of complex niche problems rather than here. Rust, I would say it's sort of somewhere in the middle. You can use Rust for crude apps, but why would you? It is sort of a little bit more towards the blue. Golang is much more here. So Golang is kind of definitely red. Rust would be sort of between, and Haskell is definitely blue. All right, let's have a break. So let me answer the question first. Yeah, so the slides are not posted yet. The thing with Mentimeter is that I have to run the Mentimeter first, and then I can post the slides. If I have slides generated before the course and they are not Mentimeter, I will post them in the lecture wiki, and you can follow and see the slides before. But the lectures that I have in Mentimeter, I can only post the slides after the lecture. So the slides will be posted on the wiki after the lecture. You can see if you go to lectures, there is a placeholder already, Menti slides, and the link does not work yet, but it will work after the course, after this class. So yeah. All right, 10 minutes break. And those of you who did not sign up for GitLab, do this, and I will kind of mark everybody in the course for those of you who did. Let me go. All right. So we are back. Before we continue with the how can I access lectures under the wiki? Yeah, so the slides will be on the wiki. And the wiki is, if you go to course PROG 2006, PROG 2006 2026, you go there on the GitLab. And then if you go to this three dashes, you're gonna get plan, and then there is a wiki, plan wiki. And then the lectures are on the left-hand side panel. So there is an about page about Haskell and Rust, and then home and lectures. So lectures are here. That's how you access it. I will, before we continue, I want to remind everybody to join GitLab and request access to the course. And then this week we don't have the lab. So today we kind of just having this longish lecture, but you still need to do some things at home. So the things you need to do at home is you need to install Golang, not for this course, but for the cloud course. So kind of download it, install it on your system. It's usually like a installer. You can use for Mac and Brew, you can use Brew to install Golang. So you can use Brew, you can use apt for Linux, and so on. So some kind of a package manager, basically. So let's say package manager. Yeah, Brew apt. Yeah, maybe if you're using something, I don't know, like something, right? So for Golang, use a package manager. For Haskell, what you want is install GHCUP. So install this via package manager. And then you will have, this is kind of a Haskell package manager for Haskell systems. And that's the best, the easiest to manage your installations. And then same install Rust app via package manager. And then you will manage your Rusts or Rust installation with Rust app, right? So typically I go GHCPU and TUI, and so this is a tool which manages your installs of Haskell. And then if you do this, it will tell you which version of Cabal and which version of sorry. So what version of GHCUP you have installed. Always use the recommended latest one. Which version of Stack do I have installed? And then you have I for install and so on. So install the Stack 371, install the latest Haskell language server, and then the latest Cabal. And then for the actual Haskell compiler, I think you should use Stack, and Stack will install whatever it needs. But I have pre-installed the one which the default Stack currently uses, so it's this one. And then I have for some modern things and some new things, I usually use the latest one, either 12 or 14. Currently I'm using 12, but I will probably go to this one once it has the language support. It's a little bit complicated. We're gonna go over it later. For now, don't worry too much. As soon as you have the GHCUP installed, install something and make sure you can run stack commands and you can generate the hello world. So in all those languages, you can generate the hello world by saying new project and blah, blah, blah. And then you have kind of a hello world, generated. So generate it and then make it compile and make it run. And then that means you set up. Doesn't matter which version you actually ends up using, as long as you have the language Haskell language server installed. Oops, sorry. If you have the tool installed, Stack installed, and language server support, you will interact with the system using Stack. So I will show you later, like next week, we're gonna spend some time in C++, and then the following week we will start with Haskell. So we will kind of, we have 2 weeks to get it sorted, but start now such that you can ask questions and we can resolve things as we move on. So this is for Haskell, and with Rust, it's even easier. So you just say start Rust up, upgrade, and that's it. And then it installs the latest versions. I have a little bit more complex setup than you will have, because you don't need the nightly builds. I'm using the nightly builds, so it kind of needs to download them every day and kind of install them. We will use just the normal 1.94. You don't need the nightly to start with. And then with Rust, once you install it, it will have cargo installed, and then we interact with systems with cargo. So you will use cargo new and then set up new project. And with stack, okay, let me clear that. So for Haskell, you will say stack new and then project name uh, to get this hello world sorted. And then for Rust, you will use cargo new and then project name, and that's it. So for this week, there is no coding, nothing to do. Just install the three systems for yourself. So Golang, um, and Haskell and Rust. Golang does not have this sort of a Golang installation manager. So you just have to use your normal typical package manager to upgrade your Golang to the latest version. And for Haskell and Rust, you will be managing the installations using Rust app and GHCUP. Okay, questions? Isn't it the best practice to not install the toolchain manager with package manager, but with the official script? Yes, you're right. It is a better practice to use the official script because then you get the best or the latest versions. The package managers typically lag behind and they a little bit behind what the language actually is at. But so this is a very good question for Golang. I tend to manage it myself instead of package manager, but um, so some tools that you will use require to have the dependency on Golang, and then they say, oh yeah, you don't have installed Golang. And it's like annoying that the package is registered with your registry or whatever. They seem not to understand that I have installed it manually. So what I do, I actually installed it via package manager and then overwrite it with the manual kind of move that I always have the latest version, but the package manager pretends that it's there as well. And for Golang, it's a little bit pain. So for Golang, yes, you probably should install it via the official Golang script or installer, but you may kind of do a little bit of manual thing. For Haskell and Rust, the GHCUP tool and Rust app tool, those are the tools which always keep the latest versions. So you can install them via the package manager or the official script. It does not matter so much because they will update themselves. So both of those tools update themselves, and the way you've installed them does not matter so much. I mean, you can install them via the script, which I think I did, or via package manager if they are available. Yes, you should prefer the script. Yeah, I agree with you. You should prefer the script, but it sort of does not matter so much because you will have the latest version because they kind of update themselves. So you can say Rust app update, and then it updates itself or upgrade. Um, yeah, I don't remember like if it keeps itself updated automatically if you're using the other commands. Anyway, to answer your question, yes, you should use the official scripts instead of package managers. But if you end up using package managers for this course, it sort of is okay. We don't have to have the latest versions most of the time. So it's okay if you lag behind a little bit. But it is a good practice to use the official scripts. All right, and then for IDEs and editors and the AIs you're using, I don't care. Use whatever you are familiar with. However, there are kind of two schools of programming. There is kind of a uh, keyboard school and mouse school. So a lot of IDEs, they force you to use the mouse a lot, and they force you to move your hands from keyboard to the mouse. And some programmers, me including, they hate this. I kind of don't like to kind of move my hand to the mouse and do things with the mouse. Um, I kind of, it slows you down and it kind of makes you a little bit less productive. It's better and faster if you're kind of in the keyboard school. So the keyboard school means you're sort of doing most of the things that you need to do with your key, with your hands on the keyboard. And for that, certain IDEs are better than others. And the one of the kind of very useful IDEs is Vim or the very old-fashioned text-based console-based editor. Um, I expect many of you didn't use Vim before, and like you are at the university, you have time on your hands, you have still 1.5 years to go and studying. And in 1.5 years, you can become like a superpower user of Vim. And it will kind of boost your productivity. Like you will actually feel more productive with editing text using Vim. It's not a requirement, but I kind of encourage you to try it out. And it's a bit of a steep learning curve. It's a bit pain to sort of be productive from day one because you have to learn the keyboard shortcuts and so on. But if you use it all the time, it becomes a second nature. And then if you move to a mouse-based IDE, you feel like, oh, come on, like it's so much worse. Again, it's not a big deal. Like you can still use your Visual Studio Code or IntelliJ. I use all of them for different things, but I tend to use Vim most of the time because I kind of work with smallish projects, and then it's kind of Vim is enough. If you have a very big project with a lot of files and libraries and kind of things like that, I tend to go with a bigger IDE like IntelliJ or Visual Studio Code. But yeah, also like lately with the AIs, I use Visual Studio Code with Claude because it kind of gives a little bit better integration than Vim. But you know, we are here to learn tools, and different tools are better for different things. So expand your sort of vocabulary and your skill sets and try things out. I don't care. I don't care what do you use. Just pick whatever works for you and whatever you want to learn, and use the next 1.5 years to learn things you don't know yet. Because maybe you will love it. Maybe you will like something that you don't know yet, and you will sort of be better using it. So that's about IDs and AIs. Regarding AIs, the labs will tell you most of the time when you have to do something at home, use AIs all the time for everything. So at home, try to learn more where AIs are useful, how to learn more about the languages and use it as a tutor. There is no problem. When we will be doing labs at school, we will tend to not use AIs. We will tend to just use our own skills, and we will try to solve puzzles and problems ourselves and code them ourselves. The reason is that it's kind of improves our ability to read code. And even if you can make AI code something for you, you kind of have to imagine it first in your head. And then being able to kind of type it first is good for learning. So we will tend in at school not to use AI. But at home, you can use AI. You can also do stuff by hand at home as a form of practice. Remember, the exam is with no AI. So in the exam, you will have to write code, and you will have to write code from your head. So practicing it through the semester is a good idea. All right, questions. Mm, yeah, so use the default one. Um, So there is a question about GHC app provides different binary distribution channels. Use the default maintained one. We don't need to live on the cutting edge. We're not exploring any of the developmental experimental features. So just stick to the default one. All right. All right. Let's continue. So Haskell. It's it has a bit of an academic feel because it is, as I said, it's a kind of a grandfather of all programming languages, and it's a playground for programming languages designers to check what works and what doesn't, and how people feel and what feels useful and not. So that's why it is kind of a lot of papers and a lot of communication about languages is done in Haskell syntax because people talk about programming languages using this kind of common understanding. It has a very extreme concise notation, which is very easy to remember once you learn it. If you don't spend time learning it, you will kind of hate it and you will hate Haskell. But once you overcome the initial notation syntax, you will, I mean, there is no way not to love Haskell besides the syntax. So, you know, try to spend a couple of weeks like typing syntax, Haskell syntax, such that it becomes again your second nature. And then reading code is super nice and super easy, and you will remember it for life because there is nothing. It's kind of uh, extremely expressive, but at the same time extremely simple. I will show you in a moment. It is functional and pure and lazy. We will spend more time about it, and it is very difficult. Like as I said, you can spend the next couple of years learning Haskell, and you will still not dive deep enough to the depths of what you can explore. It's a very rich and very powerful language, and it's extremely interesting to use it. Um, so there is a question about path. Um, right. So this is a good question. So if people can open the, I don't know if you can see my um, question window from Zoom. Zoom tends to hide things. Um, but anyway, there is a question in the Zoom chat about path variables. So all those languages and all the compilers, they have an executable. An executable has to live in your path. And then where do you place it kind of makes it like the path dictates the order in which the executables are picked up. And we usually manage it by bash rc, and if we live in bash or some other shell rc file, which is used for setting up the path. And the question is, should we prepend it at the beginning? Should we append it at the end? Or should we don't include it in the path? So you should definitely include it. The question is, should it be at the beginning or at the end? And it kind of depends. Sometimes you want to prevent like normally when something goes at the beginning, it means it's gonna be picked up. So let's say I'm writing a malicious script that pretends to be a Go compiler, and I want you to use it instead of the real Go compiler, such that I can do some malicious things and compile your Go code, right? And I want it to be the first one to picked because I don't want the official Go to be picked. So then I would say go and prepend it at the beginning, right? So malicious code usually asks you to be the first one such that it kind of bypasses the real one. But if it is the real one, you want it to be the first one such that if the malicious code is appended at the end, it's never picked up. It's the real one, which is at the beginning, which is picked up, right? So it's a little bit, there is again no correct answer. Whether you should prepend it or append it, it's sort of your decision. Typically, the real things that you really want to be picked and be sort of secure should be prepend, should be at the beginning. And everything that you kind of don't really trust or you don't know exactly, what it may or may not do, you usually should append at the end. Again, it depends. I cannot tell you what to do in general case, but in this particular case, for the compilers, make them at the beginning. So prepend them kind of at the beginning. So you pick the option P, right? All right. So this is okay. So what I'm gonna show you for a very short moment is C++ code. Okay. So I'm gonna show you a C++ code. You're gonna read it, and then I will ask you some questions. Okay. So this is the code. Whoops, sorry. Okay. So now the question is what this function takes as a parameter and what it returns, and what is this function doing? Can you answer? Okay. It's a little bit unfair, right? Because you didn't know what to look for. So I will show you the code one more time, and you have to kind of tell me what is this function taking as a parameter and what it returns, and what is this function doing? Okay. So now can you tell me? How easy it is? Yeah. Nick kind of nailed it. So it takes a vector of ints and returns what? It returns an int. And Nick has used this sort of a Haskell notation to express what it takes and what it returns, because it's kind of nice. Um, so let's see. So we're taking a vector of ints. And then we have a lot of decorations. We say it's a const. We say by reference, and we using generics for our vector, and we're returning an int. So there is a lot of text to convey what's going on because we have to be quite precise, right? In C++, we have to be very precise what we really mean, and then we have this const and this ampersand there. And then what it does, right? So we have some kind of loop. We're looping through the vector, and then we checking something. What we are checking? We're checking if they are even, right? So we're checking if the numbers are even, and then we having an accumulation. So here we're jumping with our eyes kind of up and down. We're saying, oh yeah, there is this accumulation. It's an int with value 0, and then it sums the squares of the x's which are even, right? So that's what's going on. So it basically is summing up through this, summing up here through this accumulator the squares of even numbers, right? And we have to jump up and down and follow this kind of accumulator to understand what's going on, which is kind of trivial, but it is at the same time quite complex, right? So the same code, the same logic expressed in Haskell is like this, right? So it's the same function. It's the same function as this one, but expressed in Haskell. So the type is we passing a list of ints and we getting an int as a return, and then we getting only even numbers which are squared and then summing them up. So it's a sum of squares of even numbers, right? It's right here in your face, right? If I now compare the ability to make bugs or make mistakes or make typos between those two codes, you can see the sort of the powerful syntax that Haskell is using for expressing a very complex function in a single line of code with very limited number of mistakes. Like if I say 3 here, like instead of squares, I have 3, or if I say even instead of odd, then, like it's so obvious, like to see typos and mistakes. And here it's a little bit more difficult. I have to kind of pay attention to this symbol um, 2 and this symbol plus, which is sort of in the noise of all the other symbols, to see that I'm not, subtracting or multiplying or whatever, right? Whereas here it just says sum, right? That's it. Like there is no possibility of making really typos here. So there is sort of a powerful expressiveness in Haskell that allows us to deal, and this is a very trivial problem. Like it's a very, very trivial thing. And if you multiply it by complexity, if you need to deal with more complex things, the complexity kind of explodes, right? So reading kind of C++ code takes more mental effort and more symbol parsing than in Haskell. Um, so we have another quiz question. And while you're joining, I will answer questions. Uh, okay, so do you enable a better integration of Stack with GHC app? And you should answer yes. And the default answer is yes, and you should say yes. So what will happen is every time Stack needs something to be installed, it will ask GHCUP tool to install it for it, and then GHCUP tool will know that it is installed, and it will kind of manage a single versions of things for you. So GHCUP is a kind of like a package manager for Haskell things and for Haskell compilers. And you can have multiple versions installed, and multiple projects can use those different versions. And then Stack is also a toolchain manager for managing Haskell projects, and it can install the toolchain per project. So if you don't do this integration, what you will end up with, versions of your compiler managed by GHCUP and versions of the compiler managed by Stack. If you say yes, you will only have versions managed by GHCUP and Stack will use them. So it's easier and better to do it this way. All right, 20 people, come on, let's do it. You can still do in quizzes. Couple more, two more maybe. Come on, come on, come on. 25, let's make it 25. All right, let's go. All right, it's a question about Haskell, Rust, and Go. They are all interpreted. Some are compiled, some interpreted, or compiled. They are all compiled. Haskell, Rust, and Golang are all compiled languages. What does it mean? It means that the source code is compiled to a native code for a particular CPU architecture, and then you end up with a binary which executes natively on that platform. No interpretation, no just-in-time compilation, nothing fancy. Okay. Great. Let's try that one. Again, a question about all three. They are all strictly typed languages. What does it mean? It means that once you declare a variable, the variable type is known until the end of life of that variable. The type of a variable is known at the compile time. So the compiler can do some reasoning and can do some back checking because the type of things is known at the compile time. That's not the case for Python. That's not the case for JavaScript. That's not the case for other programming languages that are dynamic, like TypeScript. All right, 5. All right. Again, 3 languages. Type inference. What is type inference? Type inference is the ability for the compiler to infer, to guess what a type of the variable is based on how it is being used or type of the function or whatever, right? So if the compiler can work it out and say, yeah, this variable is of string without you telling it in the code that it is a string, that's called type inference. And all those languages have the type inference, which means in many instances, you don't have to say what type something is. It will be inferred automatically. It still means it's strictly typed because everything has a strictly well-defined type. It's just that you as a programmer don't have to say it. It will be inferred by the compiler. Okay, so we have 3 languages which are strictly typed, which are compiled, and they have type inference, right? So all compiled, strictly typed with type inference. Why we learning 3 languages like this? Yep, they are good, they are robust, all good answers. Mm, yeah, so they easiest to use. They are not necessarily the easiest to use, but they are the easiest to manage complexity, and they are the easiest to not have bugs and to have really large systems. So for large complex systems that needs to be built, like remember the bridge which had the suspension and concrete and steel and like very solid design. Those are the languages that we need for those type of bridges. We cannot do those type of bridges with languages which don't have that. So languages which are not compiled, not strictly typed, and without type inference are really not well suited for very large complex systems. Those are the languages that we use for serious programming. If we need to build libraries, frameworks, and things that are robust and maintained and solid, we use languages that are that. Um, all right, so we should have another break. So that was the first break to have. So you see how bad I am with breaks, right? I would keep you here for 3 hours straight with no breaks. Good that you reminded me. Question. There is a question about some problems. Right. All right, so let's do some troubleshooting, and the rest of the class can have a break. So the question is about an error when installing Haskell. And GHCUP complains that there is no C compiler in the path. which means you will have to install GCC or LLVM or something which provides ability to compile C. Probably GCC. Uh, I Okay, let me just stop recording. Okay. Right. So there is nice comment from Nick. I will copy it and paste it into this page. Just give me a second. Thanks, Nick. So installing for Linux and then example for Mac OS. Let's be nice and tidy. I think it's spelled like this, maybe. Yeah. Okay. All right. So you do it in the command line. This one for Mac. And for Windows, yeah, for Windows it's kind of much more complicated. So I will try to do it in the issue tracker afterwards. All right. Uh, Build essential. Right. So Christian has some issues with the fetching of the dependencies. Make sure maybe you have to do. Okay, let me see. Maybe you have to do update and apt. So do update and upgrade first, and then do the other things, and make sure your network works well. So sometimes there are some kind of obsolete things. Anyway, we can troubleshoot. As I said, it is no panic. Take your time. If there are some problems, we can solve them next week anyway. And if you have some issues, just post them into the issue tracker, and we can resolve that. Okay, so another example of why we learning Haskell and Rust, and we not learning all the new concepts in C++. Okay, so here is a problem. We have two strings, which are under variable W string and H string, which stands for weight, width, and height. So we have a rectangle of width and height, and the data is given as strings. And then we have to calculate area, which is just, width times height, and the perimeter, which is width plus height double, like twice, right? Otherwise, we should fail. So all we need is a function which, given two strings, parses the strings into numbers and then computes area and perimeter. Okay. It's again a very trivial problem. It's a very simple problem, but at the same time, it's a very complex problem because we have to error handle. Like parsing the width or the height can fail because they might be like the width and height are given from by the user, from like the user gave us those two, and then they may fail. So if they don't parse, we should fail, and if they parse, we should calculate this and this, right? So it's kind of a very trivial problem, but at the same time, very interesting. Like, how nicely can we do that? Can we handle errors and can we compute those two things in a way that is sort of nice and easy to see what's going on, right? So here is the um, code written in Rust, which does that for us, right? So it basically it's a matrix. It's the function will be called matrix, and the matrix function will take two parameters and produce a tuple of two results, area and the perimeter, right? With those two calculations. If parsing of those, if any of them fails, we should just fail, right? So in the Rust, what we do is we have a function matrix, which are given two strings, width and height, and then it returns an optional value. What is an optional value? It's like there is a value or there is nothing, basically. So it's sort of like with C, we have a value, like if the value is by reference, we have a value or a null, or null. So then if we have null, there is nothing, there is no value. If we have a value, then we have something. So option is like that. And the tuple is two things, like one, the first thing and the second thing, right? And in our case, the first thing is the area, the second thing is a parameter. So that's what the function is. And then we're doing the parsing of integer. So we're parsing them into ints. We assumed the width and height are integers, and then the results are integers, which is fine because we have it in the spec, right? So if both parse as integers, okay, so we kind of assume those are integers. So we have I32s. We parse the first one, which is width. If it is okay, we zip it with the second one. If it is okay, because if none of them is okay, we return nothing. We shortcut here. And then we do actual calculation. We calculate the area as the first, and then we calculate the perimeter, right? So you can see that the Rust has all the concepts. The syntax is a little bit kind of, it's okay, but there is a lot of symbols, right? The same, like what is important here is the function definition with the two strings being passed and the optional value kind of being returned, and the parsing of the width and of the height. And if any of them fails, we should fail. So we return nothing. And then this calculation of the area and the perimeter, right? Those are the important things. Everything else is sort of like a syntactic fluff. It's like a noise that we have to deal with, right? So then this is Haskell. Exactly the same concepts, exactly the same parsing, and exactly the same calculations. So we clearly see we calculating the area and we calculating the perimeter of the rectangle. We clearly see we reading and parsing the width and height from strings, and that's it. There is no kind of noise. There is no noise, symbolic noise kind of in this notation, right? So it's very concise, expressive, and there is almost no boilerplate. And this is C++. In C++, again, we can do this. We can use the optional optional, and we can use the pair for the tuple. So C++ offers us optional and kind of a pair types to do exactly the same thing, but it does not give us the parsing automatically. We have to implement our own parsing, which takes a string and returns us an optional int. So there is extra thing that we have to do, and there is an extra thing that we have to use, right? So this is amount of symbols you have to do in C++. This is amount of symbols you have to do in Haskell, and this is the amount of symbols you have to do in Rust, right? Questions? Yes, so I32 is a 32 signed integer in Rust. So you see the concepts are the same, but discussing the concepts here is very noisy because to explain what the concepts are, we have to deal with a lot of syntax and with a lot of extra things that we don't have to deal when we talk in Haskell. In Haskell, it's a very pure kind of like, it's only about the concepts. Here, it's, yes, the concepts are here. It's just that there is a lot of extra things. And then Rust is sort of a little bit in the middle, right? It has the optional type built in. It has the parsing built in with optional values. So we don't have to do the same as in C++, define our own. But it is more noisy than Haskell in terms of like syntax. Concepts are the same. Parsing string into integer with optional value is the same in all three. It's built in into Haskell natively. You don't need anything extra, and you don't really need any extra syntax because it's part of the core language, same as in Rust. In C++, it is part of the language, but we normally don't write code like this. We use references and null if we can get away with it. And this is what we kind of did here. Like we do have this null pointer, null option check. So anyway, to learn about the concepts and more complex concepts, we will do Haskell and Rust. Why we don't start with Rust? Because it has a lot of extra. It has a lot of noise anyway. It conceptually is the same. It's just the way you're expressing it, it's a little bit less tidy. It's more tidy with Haskell. And it's easier to understand optional values and how they are processed and how they are used because the syntax is sort of simpler. But you do need to learn the syntax. What is parse? Yeah, so parsing is turning typically a string representation of something into kind of a native representation of something. So if I have a string, which is like, let me show you. So if I have width, which is a string, and it's 12, and I have height, which is a string, which is 2, right? I cannot say this because it doesn't make sense. It doesn't make sense to multiply two strings unless you live in a world of JavaScript, which is a very Alice in Wonderland type of experience. You may be able to do this, but in most programming or scripting languages, you cannot multiply strings together, right? So parsing is turning this into a number, which is 12, and turning this one into a number, which is number, which is 2. And then if I do that, and if I say this is W and this is H, then I can do H times width times H, because it will be a number, right? So number times number is number, and that works. But strings times, like what the hell that should be, right? We cannot multiply strings. So parsing is converting string into something that is not a string, right? Another example of parsing is I can convert a tuple, which is a string like this, into a tuple, which is actual tuple, right? So the type of this is tuple. The type of this is string, right? And the process would be parsing. All right. Okay, let's move on. What matters is the concept of tuples, optional types, composition, safety, type safety, error handling. This is what is important. What is not important is the syntax, because the syntax will change depending on which language do you use. There is a caveat, okay? Not all languages are made equal, and some things cannot be expressed in a language. And if you try to express it in the language, you will hit kind of a lot of problems. And Go is one of those, like C and C++ also, but Go specifically is one of those languages where we don't have certain constructs which other languages have, and we have to just use what Go offers. and then we miss the features, right? So the community, the programmers were using Golang for many years, and they were missing generics. And they were saying, why Go does not support generics? And then the designers, the maintainers of the language kind of gave in and say, yeah, okay, generics is a good idea. Let's have generics. Same might happen with optional types. Like, why do we don't have optional values? Why have we deal with null pointers for non-values instead of optional? Maybe in a few years they will end up in Go, but currently they don't exist. They do exist in C++, and then you can use them, but in Golang you don't have it, right? Okay, so there is an update from Christian that updating all the packages helped to resolve some build essential problems. So do the apt update and upgrade first, and then continue with your Linux installations. Right, so let's move on. Otherwise, I'm gonna go over time. So like 4 hours lecture, and like we running out of time. So let's speed up a little bit. So two more questions. All right. One more? Perfect. Please join in if you still can. And let's do it. So C and C++, right? So those are languages you already know. Both have type inference. They do not have type inference, or a combination. All right, so surprise, surprise, C does not have type inference. In C, you have to say what everything is, and there is no way for you not to say what everything is. So no type inference. But in C++ 11 and 17 and onwards, we have the keyword called auto. And in C++, auto means, hey, compiler, infer what the type of this thing is. I don't bother to type the type for you, right? So instead of saying all the variables, what they are, you have this, you can say X, and you can say auto. And then auto means, hey, compiler, do it for me. I don't bother typing to you what X is. So C++, modern C++ has a form of type inference for auto. Does it work all the time? No. Sometimes it does not work all the time, and same in other languages. Haskell and Rust also have type inference. You don't have to say what type it is all the time. Sometimes it can infer what it is, but sometimes it infers wrong, and you have to tell it, especially in Haskell. So it's a good idea in Haskell to kind of have function declarations with type declarations, because Haskell can work out what types things should be, but sometimes it works out a kind of a thing that will work in special cases, but not in the case that you want, and you want a different type. Same in other type inference languages. All right, so how we are doing now? Oi, Mina is not adding value anymore, so there is a small change in the latest iterations. All right. Yes, the course, we are focused on individual study at home, and in the classroom we will use teamwork most of the time. It's a balance between practice and theory, so probably that's a balance between coding and programming with kind of concrete syntax and theory about languages. And the practice is very important. We cannot have theory without the practice, but the theory is also important, especially when you're working with AIs and you need to communicate what you really expect the AI to do for you. So because practice is important, you cannot get fit by delegating things to the AIs or to just watching things, right? So watching lectures and participating in lectures and like reading code from the lectures is not enough. You have to write code yourself. So you cannot get fit from watching tutorials of how to exercise and watching somebody else going to the gym. You have to go to the gym and you have to lift the weights yourself. And that's how you get better. So you need to practice, you need to code, you need to solve puzzles, you need to write code, and you need to read code. Um, of course, when you dictate, like when you make a prompt to the AI and it does not what you want and you refine your prompt, you're also doing practice. You're practicing prompting and you're practicing expressing what needs to be done in a more precise way, such the AI tools will do what you want. Um, that's practice too, but that's not enough. You have to write code yourself too. All right, so why do we learn theory? There are many reasons for it, but you need to know the theory and you need to know the vocabulary to have meaningful communication with other team members in your team and with the AIs, and also having good semantic conceptual understanding of frameworks and theory helps you pick up new languages and new frameworks very quickly, because the only thing that will change is syntax. Everything else you will already know. So I don't know what language you will use in 5 years or 6 years time. The language's landscape changes, everything changes, and I don't expect you to be using the same languages forever. You will use different frameworks and different languages. So knowing the theory, knowing the foundations will make you robust and will make you sort of safe for the future. Also, knowing the theory helps you to talk with AIs and get the job done correctly. AIs often make mistakes and make misjudged kind of things. And then you need to correct it and you need to have the vocabulary to say exactly what needs to be done. All right, so the final quiz question that will define the winners of today's episode. All right. Perfect. So, all right, it's about C++, modern C++. Whew, 50-50, you can guess, right? So you know concept of functions and you know the concept of polymorphism, and now you have to combine it and you know your C++. I can see most people, with one exception, maybe it was a kind of a mistypo or typo, misclick. You know your stuff. Good. All right. So how do we see the right? Nick is catching up. Right. Crown. Congratulations. Well done. And Nick number 2. Okay. So how much time do we have? Okay, we have a little bit more time. So the final thing. Programming is quite a complex process. This definition that it is a process, it's a good one, but so it's a process of creating symbolic representations. So we create those symbolic representations all over the place, from like the requirements specification, talking with the customer, talking to the project lead, down to requirements, listing, functional requirements, non-functional requirements, down to specifications, implementations, testing harnesses, all the like it's everywhere, even in prompting. Like when you prompt AI, you're creating some symbolic representation of what you have in your head to text, such that AI can kind of deal with you, right? So we wear those different hats, okay? And we often take it for granted that it's quite a complex process. And we need to be more aware of that process and a little bit more structured. Okay, so here I have a very trivial problem for you. You need to write a command line app that you asks a client, kind of a customer or user, about two numbers, and then returns a sum of those two numbers back. How hard is it? Can you do it? Like, can you do it right now in any language you want? I think it's not very hard. So what additional questions you may ask the customer? What else do you need to ask? Okay, what we're doing is it's a command line app. So, you know, command line app like this in a shell. So let's call our app. You run it. It says, oh, give me the first number, give me the second number, and then prints you the sum. Okay. So now the question is, good. How big are the numbers? All right. Good. So what type of numbers are we dealing with? Floats, biggins. So the reason why we need to ask it is to know what our variable needs to store, like how big our variables needs to be. Like, is it like numbers between 0 and 255? Then we can use a byte. If it's like, you know, negative numbers or positive numbers, we can use signed or unsigned ints and so on, right? So yes, the size matters. What else? So let's say the customer, we ask the customer, negative numbers and the size. Yeah. Precision about the floats. Yeah, so I'm answering you. The numbers are between 0 and 65,000 and they are positive only. Okay. There is no unit. There is no currency or those are just numbers. Okay. No floats. Those are the numbers will be integer type, positive, up to, you know, I32. Okay, why are we doing it? Yeah, that might be a good question. What else would be a useful question? Yeah, the user knows. The user knows that the system adds two numbers. What would be a very useful question, which often when you giving a task to AI, AI does not ask. The AI assumes. Yeah, we want the results to be, this is like how fast is a non-functional requirement. Like how robust or how performant or like how fast the implementation needs to be. Those are kind of non-functional requirements, which are important. Yeah. What else? What else is a very good question to ask, which AI systems almost never ask? Yeah, that's also a good question, but that's not what I'm looking for. Okay, so the question I'm looking for is, can you show me? Yeah, the customer usually don't care. The product lead will care about the tech stack. The customer usually don't care about how you implement it and what is behind the scene. They just need the solution. They need the robust working solution. Okay. So the question that usually is very good to ask is, can you show me an example? Can you give me examples of how the numbers look like? And the customer gives you this. And then you say, oh shit, the numbers are binary. Right? Did you thought about that the customer numbers are in binary? I don't think so, right? It's very surprising, but it's very common. It's very common that the customer has something in their head which they know, it's obvious to them. It's obvious to them that the numbers are binary, right? You are programmers, you're computer scientists. Like, what else did you expect, right? The numbers are in binary, right? What does it change? It changes the parsing. It changes the way you need to convert what the customer gives you, like from the command line. Like, we call an app. The app asks you for numbers, and then we enter the numbers here, and those are strings. And to add them, we have to convert them. So it changes the way we parse. So if the numbers are binary, we do it differently than if the numbers were, integers, like decimal integers or hexadecimal integers, or if they were just, decimal and so on, or Roman, right? So we wear different hats. We often do it interchangeably. We often do that very quickly. So we are the analyst sometimes. We do talk with the customer what the requirements are, what the specs are, what the functional, non-functional requirements are, and then what the problem is. And then we crafting in our heads what the solution might be. So then we say, yep, okay, we know the numbers are binary. We need to parse them into decimal. Once we parse them into decimal numbers, we can add them, and then we can print the decimal. We need to ask the customer, do you want the result to be decimal or do you want the result to be binary, right? Because we need to write the presentation. So it's all about requirements and specs and about crafting the solution. Once we solve all of this, once we do this, then we do coding. And the coding more and more is done by AIs. So we typically, and I expect you going to the workplaces in like 2 years' time, you probably will be doing it even more than today, but it's on the rise. The coding part is delegated to the AIs. Can this be delegated to the AIs? Not really. It's kind of like very human-centric activities, and you usually interact with humans to do this right. So a lot of activities which are in this space will continue to be done by humans. A lot of activities which are done in this space are probably being delegated to AI tools, which is fine. But you need to check if the code generated by AI tools does what it's supposed to do here, right? And then we have this validation and verification, which to some extent matches with this. It has to match, right? And you may be tempted to delegate this to AIs as well, but it often backfires. So I had a lot of cases where I ask AI tools to write tests, and it does. Kind of, if you prompt it well with the edge cases and edge conditions, it does test generation quite well. But then what happens is some of the tests later, when you're expanding your code base, may fail. And a lot of times, what AI tools do, they change the tests to work instead of changing the implementation. And often the implementation is wrong. And then if the implementation is wrong and you change the tests to fit what is wrong, you end up with wrong implementation and wrong tests. And that's a kind of a pitfall of AI tools. So often in here, you really need a human because AI tools just cheat. They cheat like hell. So it's kind of funny to catch that, but it's also a very painful learning lesson that there are certain things that AI tools are quite good at, like that part, but not really good at that part and those two parts, the specs. All right, so we will use AI, as I said, we will use AI quite a lot to this, but we will still do some manual coding ourselves just as a practice, as craft. So craftsmanship means you kind of practice the craft you kind of doing, and you need to be quite skilled at it. And without practice, you cannot do it. And that will be tested in the exam. So the exam is 40%, no aids, no tools, no AIs. You just have to code yourself. And then portfolio. I will talk more about portfolio later once we have this sort of plan for the semester, and once we kick off with some of the labs. Then you will know how the portfolio works. All right, you can ask me anything. We're not gonna do that. So you can ask me anything in the issue tracker. Please sign up for the course and get your personal workspace generated by next week. So I will make an announcement when this happens. And for next week, we will do a little bit of OO modeling and design with C++. So refresh yourself how to use classes and how to use C++. And then we will do the first exercise with object orientation and why sometimes it's not the best way to like what are the good and bad ways of using it. So we will talk a little bit about that next week. If you have questions, we still have some time, so you can ask me. Otherwise, I will close for today. It was a very long lecture. Typically, we will not do that. We will have some theory part and then we will practice. But because it was a bit of an introduction to the course, and because I wanted to kind of highlight where we want AI to be used and where AI are not really that good, I sort of spent some time diving into the nature of the course. Okay. So, okay, so there is a question about the installation guides. So let me jump to the wiki. If you go to home, you have yeah, so you can navigate to About Haskell or go through this link, other Haskell resources, and the same for Rust. And then for Haskell, at the beginning of the resources, there is installing stack and GHCUP, and I kind of posted some very rudimentary prerequisites. Yeah, so let me add one more thing. So for those of you who are on Linux, before you install sudo apt update and sudo apt upgrade. This will kind of refresh your package manager cache and installed stuff. And then this command will work without problems as confirmed by some students already. So this is good to do before you update the essentials. And this is in Haskell, about Haskell on the wiki. And then here. For Windows, so this covers like Linux and Mac. For Windows, it's more complicated, and I will post Windows instructions on the issue tracker when I dig it out from previous years. I remember there was a kind of a tutorial written by a student from previous years, and that turned out to be quite useful. And I will dig it out and post it as an issue in the issue tracker. And I will make an announcement about it through Blackboard. All right. One more question. Can you tell me if I display the chat? Do you see the chat or you don't see the chat in the video? Yeah, that's what I thought. Great. Okay. Thanks. Any other questions? Okay, if not, thank you very much for participating. Thank you very much for participating in the Menti. I will update the Menti very shortly after the lecture is finished, and then posting the video will happen, but not immediately. So the video link will happen. One more thing about the videos. So if you go to lectures, you often see that I include past year videos. Should you watch them? No, you don't need to watch them. There will be like a this year video posted. The last year videos are there just for reference for those who kind of want to check what's new and what's different. But it's not needed to watch the past year videos unless I say you should watch it. So why do I post the last year videos? I don't know, just for the reference. So that the other, if someone needs clarification or something, or wants to have a kind of a different perspective on the same thing. That's why I posted. They will not be every time, but you know, the rules and everything that was from last year or previous year does not work anymore. Like you have to follow this year course. So for this, you don't need to watch the past year videos. If I do say you do need to watch it, then I will explicitly say it here. Otherwise, only watch the latest one. But as I said, sometimes I did record some like chat or instructions previously, but it's really difficult to sort of find it. Yeah, anyway, yeah. So you don't have to watch it. That's the bottom line, unless it says so. Okay, so thank you very much. Thank you for participating and have a good day. Yeah, bye bye.